If you've ever wondered how SAS actually runs your code or why that missing semicolon breaks everything, this is the video that will make it crystal clear. I'm Clark, and after 20 years working with SAS across data science, engineering, and platform migrations, and presenting around the world about SAS programming, I've seen how understanding the syntax can completely change the way you program. I'm here to PROC accelerate your understanding of SAS programming. Let's break down how SAS really works, from statements and steps to what's actually happening behind the scenes when you hit run, with some of my personal tips added. Let's start with what makes SAS unique. SAS isn't a procedural language like Python, C, or R. It's a data flow language, meaning it focuses on how data moves through your program. This means it does not run one command after another. When you write SAS code, you're really describing a process that data will flow through. Behind the scenes, SAS reads each observation from your input, flows it through the logic you have written, outputs it if it meets your condition, and repeats that process automatically until there is no more data. Here, SAS isn't running the code line by line, it's moving each observation through the data like water through a pipe. Think of SAS as plumbing for data, not a line-by-line script. Every SAS program is built from statements, and these can be grouped into steps. A SAS statement is just one instruction. It always ends with a semicolon. That semicolon tells SAS, "I've finished this command." Miss it, and SAS will merge two statements together, and that's when things break. Most SAS errors come from a missing or misplaced semicolon, meaning that semicolon isn't optional, it's everything. Now, there are two main types of statements: global statements and step statements. Step statements appear inside a data or PROC step, and they control how data is processed or analyzed. Global statements can appear anywhere in your program. They stay in effect until you change them or end the session. They don't belong to a data or PROC step. They control the SAS environment or define references. You can write them in a data or a PROC step, but SAS will just ignore that. It will run them prior to executing that step. Some examples are shown here. A libname statement shows you how to define a name or an alias known as a libref for a folder of SAS datasets. Similarly, a file name statement allows you to define a file ref to an external file, like a text or a CSV file. A title statement defines the title you want to display on your outputs, and an option statement allows you to set environment options for your session. Now, let's look at the two main kinds of steps in SAS. The data step is where you build or transform data. You describe how each row should be processed, what to read, what to calculate, and what to output. In the examples shown, SAS reads each observation from sashelp.class, calculates BMI, and then adds a category. A PROC step, short for procedure, performs a predefined action on your dataset, like sorting, summarizing, or printing. Each PROC has its own purpose, its own collection of statements or options. Some PROCs, like SQL, datasets, or IML, can perform multiple actions and must be ended with a quit statement instead of run. Use quit only for PROCs that can perform multiple actions, like SQL, datasets, or IML. A quick reference of the differences between data and PROC steps are shown here. Remember that a PROC step is predefined by SAS out of the box, where a data step is user-defined and capable of very complex calculations. Most PROCs will process all of the data at once, whereas a data step can only process data line by line. So use the data step to build your story and then use PROCs to tell it. So what actually happens when you click Run. SAS doesn't just start executing your code immediately. It goes through two distinct phases, compile and execution. In the compile phase, SAS is reading your code to understand what needs to happen, but it's not processing the data yet. It checks the syntax, identifies variables, and builds the program data vector, or PDV. The PDV is like a temporary workspace in memory where SAS will hold one row of data at a time. It can also set up some automatic variables like the _n_ variable for the observation count and the _error_ variable for error handling. Any SAS syntax mistakes are written to the log before anything executes. Once SAS has successfully compiled the step, it moves on to the execution phase. Here's what happens under the hood. SAS reads one observation at a time from your input dataset, loads it into the PDV, executes your statements in order, writes that observation to the output dataset, clears the PDV, and loops back to the next observation. That loop continues until the input data ends. And that's why SAS is so efficient. It processes one row at a time rather than loading everything into memory. SAS reads your code twice, once to understand it and then once to apply it. Now that you know how SAS reads code, a lot of weird errors suddenly make sense. If you reference a variable before SAS defines it, like calculating something before your set statement, SAS hasn't compiled those variables yet, so it errors out. If you try and calculate a running total without using the return statement, SAS resets the PDV every loop, so your total never adds up. An if statement only works inside a data step, not in open code. Some procs never close without a quit, like PROC SQL, and you'll be left wondering why SAS is still running. Most bugs aren't logic errors, they're flow misunderstandings. Let's recap what we've learned. The 6 things to remember are that SAS is a data flow language. Data moves through the steps, not line by line. Every program is built from statements and steps. Data steps build and transform data sets. PROC steps analyze or report on them. SAS runs every step in 2 phases, compile and execute. Most errors come from misunderstanding that flow. Once you've understood how SAS reads and runs your code, everything else becomes easier, from debugging to writing more efficient programs. I'm Clark, thanks for watching, and remember, every SAS program starts with understanding of how SAS really works. And a good YouTube video ends with a quit statement. Bye-bye. Want to take this even further? Tap the video right here to learn the next SAS secret and hit subscribe so you don't miss what's coming next. I'm Clark, thanks for watching CoderClark, and see you in the next one. Bye bye.